All right, when we were last looking at this, we had 3 examples left to go. Let's take a look at this one here. When looking at the names, it is kind of beneficial to kind of start from right to left because your root and your suffixes are usually on that side. And so I can see I have an alkane here, and I can see it has 7 carbons. I do not see any cycloprefix, so this is a straight or branched chain of 7 single bonded carbons. So how about we do the line angle? There's 1, 2, 3, 4, 5, 6, and 7. Now I have to figure out where those branches are, and I can see in the name that there are 2 1-carbon branches, 2 methyl groups, and they are found at carbon 2 and 4. So I can draw this either from left to right or right to left, doesn't matter. Please just don't get programmed in left to right. But if this is carbon 1 here, then there is a single 1-carbon branch there, and another one here at carbon 4. 1, 2, 3, 4. Okay, and so any sort of zig and a zag or terminus in this line angle formula helps us out. If we wanted to show this maybe in a condensed structural idea, then it might look a little bit like this. So there's 1 carbon. I can still follow my zigzag idea if you like. Okay, and in a condensed structural, remember we don't show the carbon 2 hydrogen bonds themselves. And we had 1, 2, there's another carbon here. That carbon there. Now I just have to put in all the rest of my H's, and so I can see only 1 bond for this carbon, so it must have 3 hydrogens. 2 bonds here, so it must have 2 hydrogens. 2 more. 1, 2, 3 for this guy here, so it only gets 1 hydrogen. This guy would need 3. This guy will need 2. 1, 3, and 3. And so there's 2 ways, or 2 different methods in which we could draw 2,4-dimethylheptane. Here's another one. 1,2-dimethyl cyclopentane. I want to do this from the right. I can see that it's all single bonded. It's 5 carbons, and I can see as well that it's in a cyclic structure. So I have a 5-carbon closed loop. And so I might do something like this. There's 1, there's 2, 3, 4, 5. Close the loop. I have methyl groups at carbons 1 and 2. So how about here and here? And you're probably thinking, well, wait, Mr. B, why didn't you start at the top or on the left or anything like that? Well, you're in a closed loop. It doesn't matter where you start. Wherever you put your first carbon would be, by definition, carbon 1. So I just randomly threw them in there. And I know they have to be adjacent for the lowest numbering strategy, because this is on carbon 1, then that's 2, 3, 4, 5. If I started with this at 1, 2, 3, 4, 5, my numbering strategy wouldn't make a lot of sense. So adjacent carbons in a closed loop would be sequential numbers, 1 and 2. All right, I still have to put in my hydrogens here for a condensed structural. You can see that this one requires 2, this one requires 2, same here, 1, 1, 3, and 3. And there you go. There is your 1,2-dimethyl cyclopentane. This one, I don't know, I guess I'm just being mean, but it is a possible one that we can do. So let's take a look from the right-hand side, and let's look for that longest continuous chain. I can see it's all single bonded. I can see dec as the prefix for 10, so this is a 10-carbon molecule. And I do not see cyclo in here, so it is not a closed loop. Okay, as we go through, I'm going to use the line angle here just because this is going to be so huge, but there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I feel like I'm helping Molly with her math homework. Okay, so there's me counting for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's my decane. Now I just have to figure out where are all of the attachments. I have at carbon 5 a propyl group. Okay, if I start on the left as carbon 1, that's 1, 2, 3, 4, 5. I have something here that has 3 carbons on it. Okay, so there's carbon 5. And so there's 1 carbon, 2 carbons, 3 carbons. The order in which you take kind of your angles and zigzags here and stuff like that, actually I'm going to change that just a little bit. Doesn't really matter. You're just trying to keep the line angle identified. New lines and new intersections and things like that do show themselves as changes in the chain. So how about we do this instead? Here's 1, 2, 3. Okay, so there's my propyl group. I have at carbons 2 and 3, 2 single carbon methyl groups. So we said this was 1. So at 2, I have this. It's the only 2 I see in the number. And at 3, I have 1. Lastly, I have to come up with my ethyl groups, and I can see I have an ethyl group at carbon 5. That is a 2-carbon chain. So there's 1, 2, if you like. And I have an ethyl group at carbon 3. 1, 2. Okay, the directions for your angles and stuff like that don't really matter here. This is a big, ugly, nasty one, but we can see all the changes to our overall molecule here. Okay, there you go. There's your other examples. I think you guys can see with all the specificity here and the variety that we have, practice is absolutely necessary. Page 366 to 365 in Nelson Chemistry, please take a look at that one. Try the example questions on page 370 and 373. There is organic worksheets on D2L under the content section if you're looking for more alkane practice. And if you take a look at the news section, all right, I've added 2 websites that offer online practice. University of Calgary has one that is quite simplistic, but you can choose specific practice like just alkanes. And I put another one on from the University of Ottawa with their LearnChem website, and you can pick different online quizzes to take. Okay, you get to choose what branch of organic molecules you want to practice, and you can practice drawing them and naming them. Now, my job is a little bit out of date when doing the quizzes on the University of Ottawa one. While it was just fine doing the online tests for entering the names for pictures that they showed you, it did not want to accept my drawings with the drawing app that they have. There was some sort of disconnect there. But you can give up on it, and it will show you a picture, and you can kind of self-mark your own there. So both are really nice websites. I found them to be very easy to use. You might want to check those out because practice is your key here. You are learning a new language, and we have to learn all the parts of it. So there you guys go. That's alkanes and cycloalkanes. Do your best with it, and we'll see how things are going next Tuesday when we meet for our session. And if I'm seeing that there's lots of questions and lots of problems with this, maybe we can throw in some more tutorial sessions, because this one usually takes a bit of discussion. Okay, good luck with it. Hopefully it goes well. And enjoy OChem.